For this first example, we need to come up with the equation of a quadratic function that has x-intercepts of positive 5 and negative 5 and passes through the point negative 2, 3. Now, since we're given information about x-intercepts, the best way to proceed would probably be to start by using the factored form of a quadratic function. And so we're going to look at the factored form. General form is a times x minus s times x minus t, okay, where s and t are your x-intercepts of your function. Now, the information we have tells us that our x-intercepts are 5 and negative 5. And so we can put that into our factored form. So x minus positive 5 and x minus negative 5, which would be x plus 5. Now we're going to use this information that our quadratic function also passes through the point negative 2, 3. This gives us an x and a y value that we can substitute into our function. Or if you want to think about it this way, gives us an x value that will generate the function value at that x value. So our value for y is 3, and our value for x is negative 2 from the point that was given. So we substitute that in for x and y. And now we have an equation where we can solve for our unknown a value. This is the last piece of information that we need in order to put together the full quadratic function for this given information. So let's simplify and solve for a. So here we get negative 7 times positive 3, which is negative 21. And if we divide both sides of the equation by negative 21, we get that a is negative 1 over 7. Okay? So we're now going to take this information and put it together to form our quadratic function. So we get f of x is equal to, the a value we know now is negative 1 over 7. And then using our x-intercepts in factored form, we get x minus 5 times x plus 5. Now, this question wasn't specific as to what form the quadratic function had to be in. So factored form as a final answer is just fine. But be careful because some questions may say to leave your answer in standard form, factored form, or vertex form. And so you need to be able to convert between those different forms as needed. Here's a similar question. This time we want to determine the quadratic function h of x that has zeros of 2 plus root 5 and 2 minus root 5. And it passes through the point negative 1, 4. Okay, now we are given zeros here. And so because we're given information about zeros, it's again easiest to begin with factored form. So we're going to start with h of x is equal to, we don't know what the a value is in the equation, so we just leave that as a. The first zero is the first zero is 2 plus root 5. And so in the brackets in factored form, we're going to have x minus 2 plus root 5, right, which is the first zero. And in the second bracket, we're going to have x minus the second zero, which is 2 minus root 5. We're also given information about this point, negative 1, 4, which would be on this parabola. And so we can use that, again, as an x and a y value in our quadratic equation. So we can substitute 4 for y and negative 1 for x. Okay. And now we just want to simplify and rearrange so that we can solve for the a value. Okay. So here we get negative 1 minus 2 minus root 5. And here, negative 1 minus 2 plus root 5. Okay, we can simplify each of those brackets a little bit further. Negative 3 minus root 5 times negative 3 plus root 5. Okay? This is actually the factored form of a difference of squares. So originally that difference of squares would have been 9 minus 5, and you can expand that step by step using distributive property to show that that is true. And so 9 minus 5 is 4, and so we get that a is equal to 1. Okay. So we can now use that a value to write out our quadratic function, which is h of x equal to, the a value is 1, so we don't necessarily need to write that in front of the brackets for factored form. But inside our brackets, we're going to have x minus 2 minus root 5. So I've just expanded this as well so that we don't have that inner set of brackets anymore, times x minus 2 plus root 5. Okay, so that's our quadratic function that satisfies these given properties. With this question, again, we want to come up with the equation for a quadratic function, but this time we are given information about a vertex point. Okay? So because we're given information about a vertex, it makes more sense to start with vertex form this time as opposed to factored form. So we're going to start with vertex form. G of x is equal to a, and then in brackets, x minus h squared plus k, where h comma k is the vertex. So in this case, 5 comma negative 3. Okay, so we can substitute that in. So x minus 5 all squared minus 3. Okay, we're also given information about this point 2 comma 1, which is on this parabola. And so we can substitute that in again for an x and a y value. So our y value is 1 and x value is 2. So in order to solve for a here, we add 3 first to both sides. So 4 equals a times, in brackets here, 2 minus 5 we know is negative 3. Negative 3 squared is 9. Divide both sides by 9, and we get that a is equal to 4 over 9. Okay, and again, we use that a value in order to write our quadratic function that satisfies the given criteria. So 4 over 9 times, and then we substitute in that vertex, so x minus 5 squared minus 3.